Picture yourself on a spacewalk, drifting in low Earth orbit. You are completely surrounded by a near-perfect vacuum. On the side of your suit facing the sun, you are being bombarded by raw, unfiltered solar radiation. The exterior material here quickly bakes, reaching temperatures of around 250 degrees Fahrenheit. But on the exact opposite side of your body, facing the dark void, you are receiving almost no incoming radiation. The shadowed side of your suit plunges to minus 250 degrees. You are simultaneously boiling and freezing. A 500-degree temperature swing exists across a few inches of protective fabric. This bizarre reality shows that the intuition we have about hot and cold down on Earth simply does not apply out here. The universe is filled with billions upon billions of stars, each one a nuclear furnace burning at millions of degrees. Yet the empty space sitting right between them rests at about minus 454 degrees Fahrenheit. If you place a small space heater in a sealed room on Earth, the entire room eventually gets warm. Our daily experience tells us that a heat source should warm its surroundings, so it feels deeply confusing that a galaxy filled with massive stellar fires leaves the surrounding room of space entirely frozen. The confusion comes from where we live. Look at this thin blue line of Earth's atmosphere. We exist at the bottom of an ocean of air. Every experience you have ever had with temperature has occurred inside this dense medium, which acts like a thermal blanket. Because we have always lived inside this protective bubble, we misunderstand how heat operates in a vacuum. To grasp why the cosmos behaves the way it does, we have to rethink the definition of temperature from the ground up. Temperature measures the average kinetic energy, the physical motion of particles. When particles move quickly, you measure high temperature. If you slow them down until they lose all kinetic energy, you reach absolute zero. If you remove atoms entirely, you cannot measure a temperature. The spaces between the stars are almost entirely devoid of matter. Interstellar space contains roughly one single atom per cubic centimeter. Without a dense collection of particles vibrating and bouncing off one another, a region of space cannot hold heat. Space isn't an aggressively cold substance trying to freeze you, it is just empty. On Earth, heat moves around mostly through conduction and convection. Conduction happens when vibrating atoms physically bump into neighboring atoms, like touching a hot stove. Convection happens when fluids or gases circulate, like warm air rising in a room. Both of these mechanisms require a physical medium. Because the vacuum of space completely lacks air or water, stars have no way to conduct or convect their massive thermal energy into the void around them. The only way energy travels through a vacuum is via radiation. Stars emit electromagnetic waves, ranging from visible light to infrared and ultraviolet, which speed outward in all directions. But radiation by itself is not heat, it is just energy in transit. Notice the harsh contrast on this lunar module. The gold foil bathed in direct sunlight absorbs radiation and bakes. Right next to it, shadows remain pitch black and freezing. The sun's energy streams through millions of miles of empty space without warming the void at all. It only transforms into heat at the exact moment it collides with physical matter. This requirement of matter creates some highly unintuitive situations. Astronomers have identified vast, thin clouds of gas drifting in deep space, where the atoms are moving with incredible kinetic energy. If you measure their speed, these clouds have a temperature of several million degrees. Yet if you were to float out of your spacecraft and into one of these million-degree clouds, without a spacesuit, you'd instantly freeze to death. This happens because temperature and heat are not the same thing. Temperature measures the speed of an individual particle, but heat is the total energy transferred by collisions. In a thin cosmic cloud, the individual atoms are moving fast, but there are so few of them that almost nothing would actually bump into your skin to transfer energy. A million-degree temperature means nothing if there isn't enough density to deliver the heat. In a sparse universe, actual physical warmth is incredibly rare. If a vacuum lacks the particles to hold heat, how do scientists conclude that the baseline temperature of space is minus 454 degrees Fahrenheit? The answer lies in a faint glow filling the cosmos. Almost 14 billion years ago, the universe began in an incredibly hot, dense state. As space expanded, that early radiation stretched and cooled. Today, it remains as the cosmic microwave background. That ancient microwave radiation is everywhere. If you placed a thermometer deep in interstellar space, far away from stars, it would eventually settle into thermal equilibrium with those specific background microwaves. Minus 454 degrees is the exact temperature that matter eventually reaches when it is completely isolated, interacting with nothing but the faint afterglow of the Big Bang. Cold is the default baseline state of reality. Down on Earth, we are insulated from this baseline. Our atmosphere absorbs solar radiation, heats up, and then physically distributes that energy across the globe through wind and weather patterns. Leave that atmosphere, and the buffering effect vanishes. Look at the glowing solar panels in this image of the International Space Station. Without air to regulate the temperature, the station requires complex active cooling systems just to survive the harsh reality of raw, unfiltered solar radiation on one side and the freezing void on the other. Without our planetary blanket of atmospheric gases, Earth's surface would experience those exact same wild swings, boiling in the daylight and freezing solid the moment the sun went down. The warmth we experience every day is a highly localized anomaly. We live in a tiny, fragile pocket of dense matter orbiting just the right distance from a nuclear furnace, floating inside an infinite ocean of cold, empty space.